Today, I would like to talk to you about the concept of a semantic data fabric. And so this session will not be a lot around the product of Poolparty. It's more around the concept of the semantic data fabric, which of course can be achieved by using tools such as the Poolparty Semantic Suite, which is a semantic middleware. I'm working for the Semantic Web Company, which is the vendor of that product, as Ellie said. But I today want to talk to you a little bit about this concept of data fabric and semantic data fabric. As you see on my first slide here, there is another logo on that, which is data.world. You might have already attended one or another session of the colleagues from data.world today. The reason why there is this logo on that is that data.world and Poolparty teamed up to create a semantic data fabric by combining the two tools with using their features to the best extent to provide a semantic data fabric. But let me talk you through that a little bit, and I'll give you some examples today. I'll show you a demo of how this can look like, and I'll give you some real-world examples of how a semantic data fabric can be applied. So let's get started. The first question always is, why should you care about this? Why is that an important topic? Why is semantic data fabric an important topic? And because we are talking here in an environment of people working in that field, I think that's not new for you. IT systems are getting more and more complex, data volume is growing, and at the same time, our customers or decision makers are demanding simpler, faster decision making, very often based on insights that are automatically discovered. So to do that, we need some kind of tools. To do that, we need some kind of help, and the semantic data fabric can help with this. I would like to start this presentation with an example, because I think it's always more relatable if you have some examples to show on how this theoretical concept can be applied. And today, I'd like to take an example from the HR field, from the human resource sector. Human resource leaders very much face an increasing pressure to drive business value and optimize costs, especially at times like this with the Corona situation and so on. They feel that pressure a lot. But optimizing costs in HR should never be a one-off exercise. It should always be an ongoing discipline, and it should look beyond just cost cutting to find, it should just look beyond cost cutting to find real efficiency gains while not risking long-term business performance and having a negative impact there. Well, that we all know is easier said than done. So taking that example, one issue might be that not seeing the full picture of your employees' skills and expertise can actually cost you a lot of time and money in your company. An employee might be spending time to solve a problem slowly or using very expensive consultants, when on the other hand side, he or she could solve it much faster and affordably by working with a colleague who has already that relevant experience and knowledge in that problem space. So one essential component is always to see the full picture of your employees' skills and expertise. And again, that sounds simple, but it requires a lot of different things, especially in large companies. It requires to have the possibility to connect and reuse data from various different data sources. It requires to put data in a semantic context. It's not just enough to have access to the data, but you really need to be able to connect the data in a meaningful way. And I'll show you in a second on how this can be done in this example. And you will need to be able to react fast and be agile. I mean, we all know that. That's what we always need to do, what we need to provide. And that means there is often not enough time to just start another big project, to set up another system, to build a new data model and so on. And so typically, the challenge that we have here is that the data and information that you need for this is siloed in disconnected systems. Poor data quality is very often the unintended consequence of data silos, and also the unintended consequence of poor data and analytics governance. So by combining this unstructured and structured data, let's think about the HR use case again. That might be HR databases, resumes on file servers, assignment lists to projects, articles written by your staff members, and so on. So by combining these structured and unstructured data, you really can start optimize costs and boost productivity by better matching your people to the problems and the tasks, and by helping them to team up with other people who already solved that task or who have expertise in this. This example I'm using also at the end of that presentation in a small demo that I'm going to show you. But now let's get back to the concept of the Semantic Data Fabric. So what is a Semantic Data Fabric? Well, the essential of a Semantic Data Fabric is it's always built on existing investments in data infrastructure. It can leverage the existing data assets like your data warehouse, your data lakes, and all the things that your organization has already built. When you think about the concept of the Semantic Data Fabric, you always start by cataloging your data assets, by making an inventory of the metadata that describes your data and making that catalog available to the organization. That's the very first step. For that, the data warehouse and the data lakes are very important here because we need a place to store the data, we need a place to govern it, to run our jobs, and so on. The data catalog is then the jumping off point for providing access to that data resources. And from there, you can start to harvest the knowledge of your organization to answer the questions about what is contained within these data sets in the catalog. What do they mean? How are they connected? And this is where the semantics of the Semantic Data Fabric really comes into play. It's about capturing organizational knowledge in a structured fashion with using linked data as an essential piece of that Semantic Data Fabric concept. And this semantic layer that I'm talking about here is always formed by an enterprise knowledge graph, which creates a uniform and unified data environment. And because that enterprise knowledge graph is such an important component of the Semantic Data Fabric, I would like to go into the theory of that a little bit to talk about what is that enterprise knowledge graph. So as I said, it's a centerpiece component of the Semantic Data Fabric. In order to build robust systems that are really accurate and manageable in the long term, what we need to have is we need to have a layer between the actual data and the content and the application which allows you to query and join the data from various different sources easily. So when you look at the model on the right hand of that slide that you have in front of you, and you start from the bottom, you can see that we start off with the existing data sources, which are very often, as said, in unconnected silos. Above that layer, there is an additional virtual data layer that links all your data, let it be structured or unstructured data. This is basically a graph version of the existing data and represents the relationships between your database content, your document repositories, your data sets, and so on. And then there comes the domain model of your knowledge domain in place. And this is very, very important part of this. This is the third layer in this four-layered architecture, and it is the so-called conceptual model. We also refer to that very often as ontology, and you have heard that today definitely already several times, as well as the linguistic model referred to as the taxonomies. So by the combination of that conceptual and the linguistic model and the virtual data graph really represents this enterprise knowledge graph, as we call it, and as we have it here as a centerpiece of the Semantic Data Fabric. And the applications that we build are really sitting on top of that. So let me make a quick excursus into a topic that I personally find is a very, very important one when we talk about this. We call it the knowledge graph lifecycle. Why am I mentioning it here? Because it's very important to understand how such a knowledge graph is actually built. How is it maintained? How is it improved? The most important thing here is that a knowledge graph always means that humans and machines need to be able to work together in an agile way. We call this the human in the loop principle. So you see here, we think that the human is a very important component of this. It's not just all about fully automatizing everything. It is about the combination of the human and the machine. So the development of a knowledge graph is always an endeavor involving several stakeholders, and it's important to map them out, and we try to do this here in this picture. There are three loops that are always working together and that are interlinked. Let me start with the first one in orange on top. This is the so-called user loop. Here in this loop, business users and data scientists interact with the data. They are not only data consumers, but also data producers. Then in second loop, the blue one, bottom left, is the so-called expert loop. In the expert loop, the knowledge engineers, the subject matter experts are modeling your knowledge, your domain knowledge, and they work on the conceptual layer, so the taxonomies and the ontologies. And then you have the third loop on bottom right, which is the automation loop. In the automation loop, the data engineers are involved. They do data cleaning, transforming, enriching of data, and all these three loops really work together, and the working together is really supported by the machine. So the aim of this knowledge graph lifecycle is always to have a balance between these three most important perspectives of a knowledge graph. First one is we want to represent the domain knowledge accurately. Second one is we want to link company data. And the third one is we want to enrich it with user context. So, but now let's get back to the concept of the semantic data fabric itself. This one is a very important thing to just keep and remember when working with knowledge graphs, but let's go back to the semantic data fabric itself. If you think of the semantic data fabric a bit as a data catalog meets semantics, then certain themes start to arise. It's all about discovery, sharing and finding all sorts of metadata and the data they describe, and doing so based on semantic models that refer to real-world entities and relationships. When we talk about the data there, it's not solely based on the physical location and the layout of the data, but it's always about the meaning of the data. When using the semantic data fabric concept, you can always also leverage natural language techniques to process unstructured data and synthesize it with structured data sources. It's a very important component because you start to be able to link structured and unstructured content and understand the content of the unstructured data sources. Then the knowledge you capture is always linked together in a knowledge graph, and I mentioned that before, and I think I emphasized already quite a lot how important that central piece is. And as a last point, I would like to mention that you always can use machine learning to automate or enhance data integration on top of that strong foundation that the semantic models and the semantic and the structured metadata catalog has already built. So let me guide you step by step through how a semantic data fabric is built. Let's start with the first step here. And you see, again, there are the two logos, this pool party and data to the world. So this is now built on the capabilities of the two tools and how they work together. All of it starts, as I said, with what you've already built. A data fabric is never a greenfield type of deployment. It's essentially always deployed in an active and heavy populated data environment. So the pattern is actually designed to be something that can be integrated into an existing environment, and you catalog and connect what's already there, what's already in existence. And that can include data sources, like I said, data warehouses, data lakes. That can include web services, APIs, file shares, knowledge bases, data analytics, data visualization platforms, and so on. The assets to be cataloged are the tables, the columns, the files, the notebooks, the dashboards, the data dictionaries, business glossaries, taxonomies, and so on that are already represented in those systems. So this is the real foundation. And it's really important to note that the data and the analysis are critical to catalog and understand. The dashboards and the queries and other bits of the existing analysis often contain the most important knowledge about what the data means, how it's been used in the past, and how it might be leveraged in the future. So it's really important to understand what's there. Then, as a second step, there are several components to an active data catalog, building towards a data fabric that is built on top of that foundation. There are catalog agents to automate the process of extracting metadata from the systems. Data can be integrated into the data catalog via ETL processes, or it can be virtualized. Data can be integrated in virtualized fashion as if the data would be in those systems. And the key of all of this is semantics. Again, we want to integrate the data into a fabric based on what the data means in terms of the real world relationships, not based on the technology choices made about how to store and manage data. And to do that, your system needs to one very important component that both data.world and pool party are built upon, and that is the knowledge graph. And here we come to this centerpiece again. The knowledge graph is really the centerpiece of the Semantic Data Fabric. It is the part that allows you to bring in your domain knowledge, to link your assets and enrich it with semantic context. So now, having built that foundation, we can put something on top of that. On top of that, we can put a semantic middleware, such as the pool party semantic suite, which will allow you to enrich your data through, for example, semantic standards. Just to name some examples, you can also use artificial intelligence and machine learning to achieve active metadata management. And of course, you can leverage natural language processing and deep text analytics, for example, to process your unstructured data and bring that unstructured data into context with your structured data. Finally, what you obviously need is an efficient data delivery and data integration component to make all this enriched data available to the users and to other applications. This is what a smart data catalog such as data.world can provide as part of the Semantic Data Fabric. So this component just ensures you have efficient ways to present your enriched content to the users. And here we talk about the well-known things like powerful search, user-friendly browsing, access for other systems via APIs, webhooks, and so on. So with a Semantic Data Fabric, just to summarize, you can connect your data, make your data visible and findable. You ensure that your data can be understood and interpreted. You ensure easy access to the data. You can offer smart tools for data curation, and you will be able to gain insights and create impactful outcomes from your data. And now I would like to show you just a quick example. We have built a demo to showcase this based on the two tools mentioned, data.world as a data catalog and pool party as the semantic middleware. And we thought about what is the best use case to show it. And we are using a real world use case, a business case that we actually very regularly hear from our customers and partners. It's about semantic matchmaking, again, in that HR field. So the business case here really is a consulting company wants to quickly find the best consultant to be assigned to a new project. And they want to do that based on skills and expertise matching to the project. The challenge that you very regularly have in that setting is that, again, data is held in various places, data silos, and in various different formats, structured and unstructured. And the matching is therefore often done based on personal preferences or on insufficient data quality. So what we have here as a solution is we are using the Semantic Data Fabric approach to access the data, to enrich it based on semantic context, and use the enriched data for an application. So let me take you through this step by step, and then I'll show you the demo. First, we have data from various sources, CVs, timesheets of the consultants, project descriptions in just a text format. As a second step, we use the strength of data.world and pool party to do four things. We access the data in an augmented data catalog, can be in virtualized manner. We ensure that we have efficient data delivery and dynamic data integration capabilities, again, via the data catalog. And then we are using the semantic middleware to utilize the tools and features for semantics based on a knowledge graph. And we also use natural language processing techniques to process the unstructured data. And all of this leads into a Semantic Data Fabric powered application that allows us to do the matchmaking as we need it. So let me show you that example here. I'm just looking, yeah, you can see that. This is our semantic matchmaker demo. You will find a link at the end of the presentation. You can try it out yourself. What we have done here is, here you find a list of projects. They are just imported from an open data source of the European Union. This is real life project descriptions we have just imported from an open data source. So I just click on one random one of this list. What I get here is I get a project description in raw text. So that was the project description we got from that open data portal. As a first step, I can create a so-called semantic footprint. So what we are using here is we are using a knowledge graph which has over 21,000 concepts of skills, occupation, topics, and so on, which is, by the way, also built by the European Union and available for free. And we use that classification to build a footprint of that project. So Pool Party has now created a footprint of that project based on the description. And in the next step, we match it with consultants. So we are now taking data from consultants, and I'm just clicking on one of them here. We have in the data catalog, we have data from the consultants. They are CVs, free, also again, unstructured text. We are creating, same system, we are creating a footprint of these people, and we are matching them to the projects. And what you see here is just one-to-one matching. So we are matching footprint to footprint. That's the first step, but we can go much further than that. We can enrich that footprint, or we can enrich that matching with using the information in the knowledge graph. So all the relations, all the knowledge that's built in the knowledge graph can be used to further refine that. And now you get much more precise results because we're using all the knowledge that is in the knowledge graph to make that matching, not just based on a one-to-one matching, but based on the meaning of the data that was extracted. And finally, what you can do also is you can use structured data. In that case, we say, consider experience level based on structured data, which basically only means that we had assignment sheets, how much time consultants spent on specific projects. We are using that structured data to further enrich the result. And I'll leave it at that point, because that is just giving you a quick walkthrough on how you can build a Semantic AI-based application, or Semantic Data Fabric-based application that immediately gives you much better results for such a matchmaking project, and that uses all the data, structured and unstructured, in a very easy manner. You just can upload new data, you just can integrate new data sources, and this application will do the matchmaking and provide results for you on a day-to-day basis. Because I know that time is already quite advanced, I'll skip my two examples and I'll leave it with this. If you're interested in that concept, please feel free to reach out to us. There is a white paper that we have written together, data.world and Pool Party. Feel free to download it. You can try the demo that I've just shown you briefly. And if you want to have a more detailed conversation with us on that topic, reach out to us, also in Slack, of course, and I'll be happy to answer your questions. Thank you very much.
Fabulous. Thank you, Florian. Yes, there is a booth for Semantic Web Company at the Slack, which you can access, and he'll be there. And just to let you know, Florian, we do go until 10 past the hour, so we have about 15 minutes left.
Okay. That's good.
We have a few people typing in the chat, but if you want, while we're waiting for the first questions, you could maybe share those two examples.
I'm happy to. Let me just go back to my presentation then. So I just wanted to give you two other examples because I only talked about the HR use case, but of course there are other use cases or other business cases where the Semantic Data Fabric concept can really help. One could be you can predict equipment failure more accurately. So this is, for example, when you work in oil fields, replacing equipment like an oil field pump can easily cost millions of dollars. And therefore you need to really anticipate when it will fail in order to provide life extending maintenance and to plan for the replacement in time. And to accurately predict that failure, you need data from various different observations, from reporting, from different systems. This is again an example where Semantic Data Fabric integration can help a lot, because for example, you have oil field engineers very often enter their observations into maintenance logs. This is again unstructured text, but that contains the very crucial context that needs to be matched with the structured data from other systems to be able to predict such failures in time. So a data solution that understands and links the text from that unstructured maintenance logs with the other data across the different sources can really improve predictions here and easily save millions, actually. And then a very obvious one is around customer experience and customer knowledge. When you have customer calls in a call center, you always need to solve problems very fast. You need to keep your customers satisfied. You need to retain their business. And the information you have about them in your database, in the single database that you have in front of you, might not be sufficient. But you can find very valuable unstructured information about your customer on the web, in social media, in other channels, and you can easily start to augment your understanding of the customer and the problem that they're experiencing. And so this enriched view that you can create here can really provide your employees that are working in the call center with a much better understanding of what problem solutions they can offer, what cross-selling opportunities are there, what upselling opportunities are there, and which ones will most likely succeed with a given customer. So I just wanted to bring in these two other examples here because we focused on the HR example, which is quite obvious one, but I think we can find in every domain, we can find an example when we think about possible applications of a semantic data fabric.
I'm really glad that we had time for those because I agree that, concrete use case examples are very easy for people to wrap their heads around and begin to understand what this powerful connected data can do. And especially when we talk about oil and gas pump replacements, I've heard about this before, and someone has told me, an oil and gas engineer has said, if you hear the pump that makes no noise, this is the one that's going to blow, right? And so once you know that this costs millions of dollars, it's a little bit easier to begin to explain the value of this kind of investment. So we have one question to begin with in the chat. Thank you, by the way, Florian, for the excellent presentation. Many compliments are coming in for you as well. Pallavi's question is, she would like to know how domain knowledge goes into graphs. Human intervention is required to make hidden domain knowledge explicit in unstructured text or documents. Is that correct?
Yeah, I said it's both. It's, of course, on the one hand side, it's the people who have the domain knowledge. So one of the things that we are really, that is really important when we develop Pool Party is that the component that allows the subject matter experts to build a knowledge graph is very user-friendly. So we thought from the beginning, what is really necessary is to enable the subject matter experts to build that knowledge graph. Because you don't want to have to explain all the things that you know about your domain to an IT person that then writes some kind of code based on what you described. No, what you want to be able to do is you want to be able to develop that knowledge graph in an easy way, and it should be developed by the subject matter experts. So that's the people part. But then I also said that it's always important to combine the human part with the machine. And there you have possibilities to automatically create knowledge graphs or parts of knowledge graphs, or to enrich existing knowledge graphs with certain technologies. So in Pool Party, you have features like linked data harvesting, for example, where you can harvest linked data sources and automatically create a first knowledge graph for you based on a specific topic that, for example, is already there in Wikipedia. Or you can use existing knowledge graphs, like the one that we used in the demo from the European Union on skills and occupations. You can use that pre-existing ones and amend them for your needs. So you don't have to start from scratch every time. And then the third part, what you can do is, and that's talking to the unstructured data that was mentioned, is there is something in the tool which is called the corpus analysis, where you can upload thousands and thousands of documents. And based on those documents, the system creates suggestions on how you can improve and amend and extend your knowledge graph, because it starts to understand the concepts in that document. So it's, as said, always the combination of the people, the human beings that have the knowledge, and the machine supporting them to create knowledge graphs efficiently.
And the right tools, right? Because it's much easier to do this in Pool Party versus pen and paper or even Web Protege or something like this. So thank you. Fabulous answer. We have another question here from Frank. How is the seamless integration with the data.world and the data catalog connected through the semantic models in Pool Party? And how is the front end endpoints, how are they bridged?
So what we have built here for that specific case is that there is an integration built between data.world and pool party, which integrates the pool party extractor into the data catalog. That means that the demo that I've shown, what you can do there is you have your data represented in the data catalog, can be uploaded to the data catalog or accessed via virtualization. And then we have done an integration into the pool party extractor. That means that you can just press a button, send all the data that you have in the data catalog to pool party to use its text extraction capabilities, analyze and assess the unstructured data, and pool party sends back all the annotated and enriched data to the data catalog, and there it's again stored in our standard formats, in RDF format. The enriched data is stored back into the data catalog. So it's a seamless integration between the two tools. The modeling of the knowledge graph happens in that case in pool party. The data is stored in the data catalog, and the integration between the two tools is done so that you can easily submit the data from the data catalog to the extractor and get back the enriched data.